Hey, hello everyone. Welcome to a new session on Cisco Viptela SD-WAN. So we'll be here for next 4 weekends, possibly covering the Cisco Viptela SD-WAN training. So I'm sure everyone has good understanding of routing and switching, basically the traditional WAN.
Yes.
Well, right. So for learning and understanding SD-WAN, normally you don't require very high expertise of basically the traditional routing and switching. Why? Because this is basically the name itself, SD-WAN is basically software defined. The main objective of SD-WAN is basically towards simplify the simplify the work basically for the network engineers basically. We don't need to remember all the commands and all. Basically you at the clicks of the mouse we should be able to configure, but maybe routing. If you want to configure routing, you can configure routing. If you want to do IGP, you can do IGP, you can do BGP. It will be just matter of few clicks and your IGP or BGP can get through. All right then. So let's very beginning basically. Let us start with, let me just so basically this SD-WAN, okay, it basically comes under the framework of SDN. SDN stands for what? Software defined networking. So people maybe maybe 10 years back, 15 years back, basically people started thinking, like people doing traditional routing, traditional switching basically for a long time basically. No, not much basically, improvements basically over the years basically. The most of the configuration being done through is CLI basically. So some people started working on like this, like why can't we have basically have a kind of a software which can allow us to do the daily day-to-day basically, the task for setting up a network, monitoring a network, managing a network, configuring the devices required for the networks. So this is what led for ultimately to this framework called as SDN, basically software defined networking. Now actually, you know in any organization, if you see basically, okay, not exactly any of, like today most of the organization basically they have three segments basically. Like always any organization will have what? All the organizations will have this part, right?
LAN.
LAN will be always there because from the LAN only the basically the network will start growing. Correct? You will have an office. In the office, you'll have some computers. You want your computers to communicate with each other. You bring a switch. You connect your devices to the switch, and the devices started communicating. Then suppose the business grows basically. Then you put up another office and then replicate the same thing in the other office. Then your requirement grows, then you want these two branches to communicate with each other, and then basically what we get is what? WAN. So when we connect two or more LAN, basically we call it as what? WAN, if the LANs are basically geographically apart. Then if the organization is big enough basically, like maybe enterprise level, multinationals and all, they will have their own. Nowadays some organizations, they have their own data centers, right? Previously before this concept of data center, previously normally in organization we used to have LAN, WAN, and maybe from security point of view we used to have what server rooms basically, or where we have the servers located in a particular segment. We used to call it as what DMZs, right, guys?
Yep.
But then now, then the requirement for this data center came in, where you wanted to host thousands of applications on maybe thousands of servers basically, and this is what led to the development of this basically vertical in the networking industry, data center. So basically, Cisco, okay, Cisco basically they basically revolutionized this data center segment of the market. Basically, they started this SDN with their offering, which was called as what? ACI, application centric infrastructure. So the SDN offering for data center basically was known as what? ACI basically. And in this ACI basically they had a, they basically, whenever we say software, basically ultimately software is like what? A program or maybe an application basically, and this application we install where? On some device, and that device basically we call it as a server, like that. Now in this software defined networking framework, this servers basically on which we install this software basically, they are basically called as what? Controllers basically. Basically always you'll have what? In SDN you'll always have controllers. So in ACI basically the controller which was available, which Cisco created, it was called as EPIC, like that, EPIC, like that. And using this software, this server, and the basically the ACI, the ACI software, they basically monopolized the data center segment. Along for the data center, they had their own product family called as Nexus, basically Nexus switches. So to configure in data center, you have basically thousands and thousands of servers to host. So naturally, you'll require thousands of maybe switches basically, and then you can't basically configure the switches through basically CLI, all the switches basically. So that is where this they're offering basically for data center was this one, ACI. Then actually, see, then in the networking industry basically the progression was like this. First LAN came, then WAN came basically, and then basically data center came. But if you see from SDN point of view, the software revolution basically, if you see, it starts with data center first, then it comes to this one, and then finally it goes to this one, LAN, like that. So this is, as far as SDN is concerned, it is basically reverse progression basically. Cisco started, like for this, after the huge success of ACI, Cisco said, okay, let us have something for our WAN also basically. So in the very beginning, they created something called as what? iWAN. So while Cisco was developing this iWAN, basically another company came in, and they came with an excellent product, and that company basically was Viptela. So Viptela's offering for WAN, they called it as what? Basically, like it is called as what? SD-WAN basically. So for WAN, we have basically what? SD-WAN. And now when Viptela comes in, basically, Cisco, like maybe they, Viptela being their competitor, they studied the market, they studied the strengths and weaknesses against their own product for SD-WAN, and then ultimately what Cisco decided that we should scrap this iWAN. Let's not waste our time and energy in developing our own product. Let's talk to the Viptela guys and let's see if they are able to merge under them, and that is how Cisco acquired basically Viptela. And now the Cisco's offering for SD-WAN is called as what? Cisco Viptela SD-WAN basically. And the software defined networking for the LAN, now it's called as what? SDA. And in SDA basically the Cisco software is called as what? DNA center. In short, it is called as DNAC. So we'll be focusing on basically this segment of SDN, basically software defined networking, that is SD-WAN. Clear, guys? Any questions on this? Yes, please.
Abid, actually, that SDWAN, Webdela, and can you explain that Webdela and Meraki? So
I'll
the
explain
difference.
that. Okay, let us come back to that. Okay,
Okay.
so as far as this thing is, whatever I've drawn, is it clear by right now, so that I can wipe out now?
Okay.
Okay, yeah. Thank you.
Yeah. So Webtela is the first creator of software-defined network on WAN, and
Yeah.
Cisco have to core it.
Yes. Now basically we are talking about SD-WAN, like that. Okay. So Cisco wanted basically, they wanted to have their presence in this domain also. Like they were hugely successful in the data center domain, and now same thing, they wanted to have their name in this SD-WAN sector. But then there were already very good competitors, and one of the competitor for Cisco was Viptela basically. Like that. They see, like if we have basically Velo Cloud is there. There are other basically vendors are also there. Their product is also quite good basically. Then, as I said, Cisco did not wanted to waste their time in any. They found their own product IWAN is lacking compared to basically, and that's the reason they acquired this Viptela. Now basically for SD-WAN, basically you have basically again in SD-WAN basically you have again two domains basically, you can say. Basically one is called as, let's say basically the market, basically the market segment can be large enterprises. It could be large enterprises. It could be basically service providers, basically large enterprises, service providers, basically segment, basically corporates basically. And then basically you can have basically small medium businesses, or basically you can have SOHO and segment kind of thing, like that. So Cisco basically acquired this Viptela. Viptela product basically is meant basically for catering to this large environment, like that. Now the question was, how about this segments, SMB segment? And this is where Cisco basically took over another company, and that company basically is Meraki. So Meraki product basically are for the SD-WAN, they are meant for basically small medium businesses or so environment, like that. You cannot have basically large scale implementation with this family of products basically, whereas this Viptela basically, since it is basically meant for large enterprise, that means you can offer the Viptela to even small customers also. It's not like only large, only like if you have basically 1000 location, then only you can go in for Viptela. Somebody has maybe only 50 locations also, they can go for Viptela SD-WAN solution. But this is basically cannot scale to a very high extent. So Cisco started offering in the market we can say two family of products, basically to cater to all this market segment basically. So we are dealing basically Viptela, because Viptela, if like somebody wants, then Viptela basically product this solution can even handle this one also. It can do this one also. This is also possible. But this one, Meraki cannot scale to large enterprises. So Viptela is more stable compared to Meraki. Basically, Viptela is more better positioned compared to the other SD-WAN competitors.
Sorry to interrupt, Prashant here. What about Velo Cloud? Is it supposed large enterprises like Viptela, or it's supposed only small network?
No. Velo Cloud is also basically meant for large enterprises. Velo Cloud is one of the you can say basically fiercest competitor for Cisco, Viptela.
Okay.
Yeah. Okay. All right.
Sorry, you meant Vela Cloud is competitor for Cisco.
Yeah.
Heavy.
Yeah. Velo Cloud is a competitor for Cisco basically.
It's from VMware, right?
Yeah, it's from VMware.
Okay.
VMware Velo Cloud.
So Vela Cloud did support multi-vendor, right?
Yes.
Okay.
Okay, then clear about your doubts regarding Viptela and Meraki, guys. They are basically two different families for originally meant for catering two different market segments, kind of like that.
Yeah.
But with Viptela, the advantage of Viptela is what? As you can scale higher, you can scale down also. And that is what, if you see in our lab environment, we can't have basically, when we are learning something, we can't have basically, 100 location environment to learn basically, because things basically only replicate. The concepts do not change based on the number of locations basically. So it can be deployed. Viptela solution can be deployed for, as I said, maybe a small organization, maybe having even 5 locations also, that is good enough. And if you have basically 5,000 locations also, then it is good basically. It can. Okay, all right. Let us know. So let us come to this Viptela now. Viptela SD-WAN basically. So we will be talking about Viptela SD-WAN now. Okay. Now in traditional WAN basically, how does a before we go about into Viptela also, let us talk about something and try to relate to SD-WAN. In traditional routing basically, in traditional WAN basically, what we have basically, we have devices, right? You have locations basically. A typical WAN kind of environment, right, guys? Suppose, let's say this is one location. Basically, you have a location here, you have a location here. Let's say we call this router 1, router. This is, let us call this basically router 3. This is basically router 2. Like that. Router 4. So you have this WAN environment now. R1 connected to maybe couple of devices, those routers connected to some other locations, basically in different locations. Now router 1 basically has a network X and router 3 basically has a network Y. So if X wants to communicate with Y, basically what we do, what guys we will do in this environment?
We perform routing.
We have to do routing, right? Maybe now if you see the number of locations and the multiple connectivity, that means the static and default routing will not be out of consideration. So naturally we'll go in for what? Dynamic routing for this kind of environment, correct?
Yes.
Yes.
So in dynamic kind of routing, basically, how R1 will learn about Y? How router 1 will learn about Y? Because ultimately X and Y needs to communicate. X and Y can communicate only when R1 and R3 knows about X and Y.
Route
We,
advertisement.
we basically configure some routing protocol on all these routers, right? Maybe since we are talking about a big environment, so naturally we'll go for, basically some organization will go for OSPF, maybe EIGRP, or maybe ISIS as their routing protocol. RIP will rule out RIP basically, because it's not meant for a big environment. So we configure some routing protocol. Okay, once we configure routing protocol, then what happens? R1 will advertise Y to R2. Same way it can advertise to all these guys also, right? It will say, yes, I have network Y. And then ultimately what will happen? R3's Y will reach R1. Like from here also it can get, from here also it gets Y, right? And then what
Yes.
R1 will do? Every router will receive this information and store in its what topology database. If it is in basically OSP will receive the information from router from its neighbor R2 also, and it will receive the information from its neighbor R4 also, and store that information in its topology database. And then once the information is there in the topology database, it will run what? Its algorithm to calculate the best path. Like if it is OSPF, it will run the SPF algorithm, right?
Yes.
To calculate the best path. In fact, all the routers along the path will do the same thing. Correct?
Yes.
That means basically in the traditional environment, every router was, calculating the best path on its own. It's not dependent on somebody else, correct?
Yes.
It will once it get the route, like R1, once R1 learns about the network Y from multiple path, it will not consider all the path as equal. Basically it will run its algorithm to calculate the best path. If it is basically OSP, as I said, it will be SPF. It is EIGRP, maybe EIGRP, it will run its algorithm dual, like that, and it will calculate, it will select one of the best path via basically R2, or it could be via R4, based on the based on the criteria for selecting the best path. Literally everyone will do the same thing. Like if you take example R4 also, R4 ultimately also will get Y via R2 also, and R4 also will get Y via R5 also, like that. Same thing over here also, if you see. So R5 also must be repeating the same thing. R5 also must be receiving the information, storing the information, then running the algorithm and calculating the best path. So in the traditional WAN environment, okay, all the routers, they used to use their own intelligence. They used to calculate their own best path for every particular destination. How to reach to a particular destination, they have to use their own intelligence. They have to run their own algorithms and all, basically. That means basically in a traditional WAN environment, in a traditional WAN router, basically, like if you see the router architecture, basically in that, we had basically something called as what? There were two logical plane. One is called as what? Control plane, and the other one is known as what? The data plane. Data plane. So we, in a traditional WAN router, basically we have two planes. So all this control plane and data plane is existing on all the WAN devices in the traditional WAN environment. Ultimately, what we want these routers to do, the ultimate aim of the routers is what? To forward the traffic. That means we want this thing to be there. We want this thing to work. But in traditional WAN, this will work only when you have the control plane. They have to calculate the best path. Once they calculate the best path, they install that best path where? In the data plane, which table is existing. In the control plane, we have something called as what? RIB.
Routing information base.
Right, in the control plane, the RIB is existing, or RIB is like conveniently we call it as what? Routing table, basically. But in the data plane, for forwarding the traffic, they create something called as what?
Fib.
Fib, like that. So fib cannot be created unless and until you have the RIB. So every router used to do the same thing. To forward the data, they have to basically calculate the best path, install the best path first in the routing table, and from the routing table maybe they compute the fib basically. Everyone agrees so far? The control plane and the data plane existing on each and every device.
Can you repeat once again?
In the traditional WAN, whenever we have a WAN environment, every router has to calculate the best path, correct? Independently. Every router has to individually calculate the best path. That means every router is maintaining what? A control plane. So in the traditional WAN environment, on a router, basically we have two logical planes, control plane and data plane existing. Out of these two planes, the most important plane is what? Basically the data plane, because that is where the actual traffic, we want the traffic to flow across a network. That is the ultimate, the goal. The business traffic must flow. End user, he says that what is the requirement of an end user in any organization? An end user will say that I want to have access to my application, like that. I should get access to how it travels. I don't care basically. A user in network X sitting over here is trying to access a server in network Y over there. He doesn't care basically. He's not bothered how the traffic flows, whether the traffic flows from R1 to R3 or like that, or R4, R2, R3 or like that something, right? They say that, okay, we want access to the servers, the applications for the business applications, what we mean. How it goes, they don't care basically. So the ultimate means the main objective of this devices, all the routers basically is what? Forwarding. That is the reason we call routers are basically what? Forwarding devices. Routers are basically the transport devices, and that means the data plane, like that. So this plane is very important, like that. But to do that, every router also has to maintain what? Their control plane, right? Every router for every particular destination, they have to calculate their own best path. This is where the designers of this SD-WAN, in the very beginning, as I said, in the SDN framework, when people started thinking of this, the one main concern was there. When they studied this traditional WAN, basically, they said, why every router has to do the calculation? Why every router has to do the calculation? Like that. Why every router must have what? Control plane. Why every router has to do the control? Why not one device will do the calculations and provide the information to all the other devices, and these devices basically then they are only left out with only one function, forwarding. So they wanted to use the routers as what? Forwarding. The original objective of router is forwarding only, but then to do forwarding in the traditional WAN, they had to do the calculations also. So they wanted that no, this calculation part they should not do. They have been designed for forwarding the traffic. Let the devices do the forwarding job. Let us have some other device basically which can do this calculation part, and that is one of the requirement of SD-WAN. In SD-WAN, the control plane will be now decoupled. The control plane is decoupled from the WAN devices, decoupled, and now it's separate. So in SD-WAN, basically, they said, since we are going to use software, why can't we have some software which will do this calculation? Why can't this software do the calculation and provide ready-made answers to all these routers? Like this software, like let's say this is somewhere basically, let's say this is some some software, some server is there basically, and this all these devices, let's assume that all these devices, let me use a different color, just showing here like dotted. Assume that all this R1 R2 basically, all the devices basically have reachability to this centralized or basically some separate server, and then this server will inform R1, hey R1, you want to go to Y, do you want to go to network Y? Yes, okay, if you want to go to network Y, go via R2. So as this software will inform R1, ready-made answer, Y via maybe R2 or maybe R4, whatever is the best, like that. And then R1 does not have to, once the server, once this software tells this R1 that, okay, Y is available, R1 will believe and install that route in its routing table. Router in the traditional WAN also, the routers are routers. They were maintaining routing table. In SD-WAN also, the routers are routers. They still maintain the routing table. But the thing is that they are not doing the calculation and installing the routes in the routing table. They are getting ready-made information about the all the networks, all the prefixes, all the routes in the network through some centralized software, like that. So that's the reason this is called as now what? A centralized control plane.
Abid Kiran here. Sorry to interrupt.
Yes, please. No problem.
Is this similar to the route reflector? Route
Yeah, in
reflector?
BGP. Yeah, you can say in BGP basically, yes, route reflector. There is some concept of similar to route reflector. Yes.
Okay, but here we are using the software based.
Yes, yes.
Okay, okay.
Yeah. Right, you're right. Basically, in route reflector also, the router in BGP, he clearly believes the route reflector. The client believes, they say, okay, the router says this is why this is via this next stop. Okay, go via that next stop. That's it basically. So same way over here also. But the only thing is that now this is not basically a route. This is not another router basically. In case of route reflector, the route reflector itself is a router only ultimately running BGP.
Yeah,
Over here it's a software basically. Okay, so
thank
now
you.
basically yeah, you will any queries, you can you can just pause and we can discuss on the questions. Okay.
Yes.
Sure.
You said it's software defined, right? So we'll be having a separate server that will have this software
yes
installed, and that
yeah
will be in cloud.
yeah it can be cloud, it can be anywhere basically. It
Mhm.
can be on a physical server also. Companies can have basically, some companies, if they have the server, as I said, no, large enterprises on, they can have their own physical servers basically they installed on. And maybe some organization, let's say some organization don't have the infrastructure basically, or the financial this thing, then the software can be housed on some public cloud. And then maybe some maybe some organization can offer this services to this thing basically, to customers basically. So this SD-WAN is basically cloud enabled. It can be in the cloud also, it can be physical also.
And the servers will be of Windows or any other operating.
We'll come to that basically.
Okay.
Like that later. Right now, let us understand this. What was the main, like the main considerations which led to the development and basically the benefit basically, like that. So now if you see this centralized control, this centralized controller or this centralized server basically will learn about all the networks will learn about all the, will rather say prefixes or routes, will learn about all the prefixes and routes in a network. And then once it learns about all the prefixes and routes in a network, then it will advertise all those prefixes to all the other routers basically. That is one thing, correct? So this is,
Yes.
this is one. So basically first thing we have is what? Now you don't have a control plane running on all the devices. All the WAN devices need not do the calculation. All the WAN devices if they suppose, as I said, there are 100 locations, and let's say there are 100 or maybe 200 prefixes, 200 segments basically they want to learn, they're not going to run the algorithms and calculate. They'll get the ready-made information. Okay, Y is available via this network, Z is available via this network, A is available via this network, 10 is available via this, like that, whatever, like that, they will get all that information, and they'll simply install that routes in their routing table, like that. And then when the traffic will come, like as we know, whenever a router receives a packet, what it does basically, it does a destination based routing table lookup and forwards the traffic. So that's its main job. And now it is only basically it become like a more kind of a forwarding device basically. Every individual router need not do the calculation. Okay. Now let us. So this is one server is there basically, like that. Now, as I said, we are basically thinking of what software. We don't want to do the things basically traditionally. Of course, when we don't want to do the things using CLI basically, but that doesn't mean that you don't have like 100% elimination of CLI, because initially the routers, you need to physically connect the routers to your network, and then initially the routers you require some basically basic, at least initial some basic configuration will be required. At least one interface must be configured with an IP address, so that it becomes reachable to the network, correct?
Yes.
So that means like initial very simple, very minimal CLI configuration will be required on all the routers basically. And then after that, what is my requirement? Okay, in let's say some organization is there basically. Okay, let's say they have 100 location environment. You have an organization, they have basically 100 locations, like that. Do you think, guys, that 100 locations will have 100 different requirements? Or maybe out of 100, maybe let's say 20 locations will have identical requirement, maybe another 30 will have some other identical requirement, like that. Like for 100 location, not naturally you will not have 100 different requirements, correct? It will not be like 1:1 basically. You have one location separate requirement, 100 location separate 100 requirement. No, there will be some duplication, correct? Some branches, like
Yes.
maybe if you see in an organization, there could be some local remote offices basically, remote branches will be there, some like that. Then maybe you can have some regional offices might be there, like that. So the local offices might be connecting to basically these regional offices, like that. Then maybe you can have basically some, maybe HQ might be there, headquarter might be there basically, like that. It could be somewhat like this, correct? There will be an headquarter. Then maybe you have basically, like if you take basically, let's say take example of India basically, then maybe this organization might have basically 4 regional offices to handle north, south, east, west basically, from in the 4 metros basically, or the major metro cities of the country basically. And then from these metro cities, they will be catering to the other locations in that particular, the cities around that metro city, correct? Like that. So somehow basically, if you have 100 locations, naturally you will not have 100 requirement. It's not basically directly proportional to the number of locations is equal, the number of requirement is equal to number of locations. It's not directly proportional. There will be something like, maybe if I say 100 locations, somebody will say, no, we will have basically 20 requirements, 20 different requirements. Okay, no problem, 20, you can have 20 different kinds of requirements. Or maybe somebody will say, we will have 50 different requirements. Okay, no problem, you can have 50, but 100 locations, 100 requirements won't be there, like that. So there will be always some kind of what duplication. There will be always some kind of what? Duplication, like that. Like in case, if you see, in case of basically traditional WAN, we have to configure OSPF, correct? In case of OSP, or let's say we take the example BGP. In case of BGP, basically we have to configure some route, like just now somebody gave a reference of route reflector. So in route reflector, basically design, what we do, basically we configure some clients, right? So whatever the configuration is for one client, basically what we do, same, we say we define maybe 10 clients. The configuration is what? Same, similar, identical, correct? And then basically, then there could be what, the route reflector itself can be what? Single point of failure. If the route reflector fails, then your route reflector design will collapse. And that's the reason for redundancy. There can be maybe a dual route reflectors, right? Like that. And when you have dual route reflectors, basically you will have basically something called as what? Cluster, basically in BGP, like that. So, but if you see that in the cluster, the configuration for route reflector will be like somewhat, duplication, right? Similar concepts, like that. So certain things, basically always, there is always duplication involved, like that. And that is what we have to do. But just think of basically in a big, like in a big large enterprise, or basically large service provider environment, ISP environment, basically where they have thousands of routers running basically BGP, like that. Like thousands of routers ultimately running IBGP. They had to do what? Basically they had to do basically multiple clusters they have to define. Basically in each cluster there could be maybe multiple route reflectors, basically, like that. How can you guys imagine how that configuration used to be done? Basically, if we go back like 20 years or 25 years back in time, manually, each and every device you have to go and manually do the configuration. Of course, people will use the script. Basically they'll create the configuration in a notepad script, and then they will do the copy paste on the device, right?
Yes.
Ultimately it is again what? Labor intensive process. Traditional WAN was what? Manual, labor intensive. Here we are talking about what? Software. Once we have the software, the software is going to do, means we want to make the work easy, all this thing. And that is where basically they said what? Let us have basically let's have a software. Let's install it on some. Ultimately when we have software, then naturally you require a hardware to run that software, basically. So you have this software, you install it on this software, and then basically what we do, basically you basically connect to this software. The administrator basically of this network will connect to this software, like that, through his laptop or something, basically, or a workstation. And then basically using this software, you are going to basically do the configuration for all the devices, like that, everybody. Centralized software. So one centralized software, you are not going to go to individual devices. Once you have this thing set up, you're not going to go to these individual devices. Initially, as I said, initially this you have to, for the initial onboarding, some IP address, because without IP address, how this server will be able to communicate with them, all these devices? It requires reachability, connectivity is needed, and for connectivity, minimum connectivity needed will be what? IP address. You require an IP address, you require some WAN service, and once you have that WAN service, and once you have that IP address configured correctly, the router is online. And once it is online, once it is reachable remotely, then you can basically, sitting on this single software, basically you will be able to do what? The configuration for one device. You will be able to do the configuration for n number of device, because it will become what? Duplication. Whatever you do the configuration, it can be easily duplicated, it can be easily replicated multiple times, as many times as you want, basically, like that. That is one thing. Second thing in networks, basically, another thing in network, what basically we have, basically, after setting up the network, traditional network, what we do, basically, after you configured, when the network is running, what we do normally? You need to do what? Monitoring, correct? You need to do what?
Yes.
Monitoring, because
Monitoring.
this is very important, because you can't believe the network to continuously keep running, and when something happens, you can't have a basically reactive approach. People would like to always have what? Proactive. Reactive as well as proactive must be there, both must be there basically, like that. So you should be able to keep a watch on your network, see how the devices are functioning, see how what is it basically. So monitoring is very important basically, like that. For monitoring in a traditional WAN environment, what we do basically, what people used to do, they used to install what? NMS basically, right?
Yes.
You'll require some basically, again, ultimately it's a third party software basically, like IBM, Tivoli, HP, OpenView, like that. So many software might be available in the market basically. So WhatsApp Gold service providers might be using. So there are so many softwares basically available in the market. So what the organizations do? They install the NMS on some, ultimately some server software, right? And then basically this will have reachability, like that. So when we are talking about already about basically here, basically so software which will allow us to do the configuration of all these devices basically. So this same software now we don't require like maybe a separate. Of course, Cisco suggests you still need to like this the software which is coming will not have like it will not have the capability identical to the professional NMS applications or software available in the market, but at least minimum basically some good amount of things are easily available inside this software itself. So monitoring now, not only configuration, monitoring can also be done from the same single window, like that. That is the beauty of this SD-WAN. You don't require separate software. You don't require separate windows to access this, basically one single window. So basically SD-WAN basically means what? A single window approach. Single window approach. Through one single window, one single screen, you should be able to access everything. One single window, you should be able to access everything. You want to go to a particular device, you don't need to go separately to a device like that. Suppose you have basically, take this example only. How many routers do we see here on the screen? Around 1, 2, 3, 6 routers you see. Let's say this is a 6 location, 6 router environment basically. We have configured all these routers are reachable basically. Basically, let's say you're sitting over here behind router, this router 6, you are the network admin for this organization. Let's say you're sitting over here in some LAN behind some basically router 6 basically, right? Like that. Can you access all these routers remotely now? Can you access all these routers remotely?
Yes.
Yes. We will configure what? Maybe telnet, you'll configure maybe SSH, correct?
Yeah.
Like that. And then what you'll do? You'll basically SSH to all these devices.
Yes.
Right? You'll do SSH to R1, you'll do SSH, and then but at any one time basically, at any one time, how many devices you can access basically? Let's say you all basically you'll be connecting to only one device at a time, even though you have telneted or even though you have SSH to all the devices simultaneously, but while configuring, you are configuring only one device, right? Like that. Suppose now, like let's say on every router, previously you had a, let's say this is an OSPF environment. Previously you had basically loopback 0 acting as a router ID, loopback 0 IP acting as a router ID. Now let's say the company wants to have a different policy. They say no, every router let us go create maybe loopback 1, assign a new IP address to that loopback 1, and then you have to advertise that loopback, and then configure the OSPF to consider loopback 1 as a router ID. So this modification needs to be done on all the 6 devices. What we will do basically, In a traditional environment, we'll connect one by one devices, right? Individually.
Yes.
Maybe you'll create a notepad file and then you will do the homework in advance to simplify your work. But ultimately, to paste it also, what you have to do individually, you have to connect to each device, right? Like that. Otherwise, or you need to have basically some programming expertise. Maybe you'll configure some programming script, maybe in Python, something. Basically, you'll create some programming script to automate your work, so that you don't need to go to individually all these devices yourself, basically, like that. But then is programming everybody's piece of cake?
No.
No.
Like that. This is the benefit of our SD-WAN, software defined networking framework. You don't, as I said in the very beginning, you don't require high level of expertise to do your job, because this will be based on what? Clicks. Everything in the background will get converted into script, will get converted into configuration. End user, end user, you don't need to be bothered how to create the script. This is similar to Windows and Linux environment. If you take Linux environment or Unix environment, you need to know CLI, correct? To do your whatever task you want to do, you need to have expertise in the CLI. Whereas if you take Windows environment, what you need to know? Windows environment provides us what? Basically, like it's a GUI environment. In
Yeah,
GUI environment,
graphics.
basically, what happens? Maybe you want to create a folder. What we do normally? Just right click, new folder. That's it. Give the name where you want that folder to be there. You specify the path. Again, at the mouse or click, I don't need to do. Whereas if you see Linux environment, if I'm on the basically root or basically somewhere, I need to basically mkdir like that, some command, blah blah blah, like that. I have to do like that. Ultimately, if you see the Linux environments also, they have ultimately migrated to GUI also now. But then still, even though Linux is having GUI environment, there are still so many things people have to do through CLI. Am I correct?
Yes.
Yes.
Now here, basically, what is our requirement is what, since we have thought of software will do the job for us, basically. And once software is going to do the job, then I don't need to do basically, I don't need to, use my own. The administrator need not use a very high level of, intelligence or understanding to do the job, basically. He'll just get basically a window environment where he'll be prompted to, input the requirements, his requirement. Like if you want to advertise network Y of IP address, you have to input that. But we clearly said, okay, you want this network, okay, give the IP address for this network, for this LAN, give the IP address for this interface, provide the interface fast Ethernet 0/0 IP address, provide the interface IP address for fast Ethernet 0/1 or gigabit 0/1, like that. And you will simply just type in the IP address like that. It will be like, menu driven basically kind of thing, a window where like you need to fill in the values in the field, like that. And then the biggest advantage is what? Basically, as I said, if let's say you want to create this loopbacks on 10 routers, you need to do only one time. You need to define the thing only one time, and you just need to provide the loopback 10 different IP address. That's it. And then the software will automatically send the configuration to the required 10 devices wherever you want that thing to. You don't need to go individually to the device and do the copy paste or do something. Everything will happen sitting basically from here using mouse, basically. So this is basically, like software defined WAN. Basically, you don't need to do things manually, basically. So configuration becomes simplified. Monitoring will be very easy. You don't require separate software as such. Of course, like this is what is there, but ultimately, if you want to really have professional monitoring kind of thing, basically, then Viptela also suggests basically some third-party software, basically. But whatever it is coming with, within itself, that is also good enough for some organizations. If they really want a very, like if you are really a large service or large enterprises basically, then you'll definitely go in for some third party softwares basically for monitoring. But as I said, on the whole, it will have inbuilt monitoring capability like that. So configuration monitoring becomes very easy like that. Another thing is now the control plane is no longer basically, individual. It is no longer basically, on every device. It is like decentralized, having its own control plane. Every device had to do the kill. It is basically centralized basically.
Yeah, with Kiran here. Sorry to interrupt.
Yes, please.
Okay, this is a basic, maybe I might have missed with your information. This server, it is shown in the diagram, right? Like below the duplication, the server. Okay, this is ideally it should be physically connected to any one of the router.
Yes.
Any one of the router, right?
Yeah, it can be connected to any one of the router, or it can be connected to all the routers also.
All the routers means.
I'll come to that, how it will be done.
Okay.
Right now I'm just giving that assume that this server has reachability to all the see, if you want to configure these 100 devices remotely, okay, that means you need to have reachability to those 100 devices from the server, right?
Okay.
Or take example, as I said, in a traditional environment, you're sitting on your laptop or some workstation behind, ultimately in some LAN or somewhere, correct? And from there, if you want to configure 100 devices, that means you require some reachability.
Got it.
So same way here also, we are assuming that this server has reachability. If server does not have reachability, then it cannot do that job basically. So reachability is paramount. It has to be there. Now it can be physical directly, it can be logically, it can be indirectly also. We'll see that how that actual thing will be there later on.
Yeah, thank you.
At this moment, assume that reachability is there. Okay.
Yeah, thank you.
I'll make that picture clear for you. Don't worry. We'll be coming to that next, because this screen is already now too congested now.
Yeah, thank you.
I'm coming to that. Okay. Clear, guys?
Yep.
Okay. So clear, the two advantage of basically SD-WAN basically is what? Basically, first thing is what? A single window approach. You're getting from single window approach. Now you will be basically doing all the things basically like that. Secondly, you have basically like there are two separate softwares. One is basically, see, when configuring and all this ultimately comes under what? If you are as you can see now, I have drawn basically in this and on the diagram basically, I have drawn, there are two basically separate software, correct? As I said, for control plane, there is a software, and then basically for this basically, management, this is basically like ultimately, configuring, monitoring, this will ultimately come basically under a management basically. Like that. So for management, basically, you have basically a software. Okay, please try to understand, it's not one single software, okay, which is going to do both the job, because this control plane basically is related to the routing, routing function basically. So for routing function, you require what? A separate software like that. So there are basically, if you see now, as of now, you have to understand now there will be basically two servers right now, or there will be basically two controllers basically like that. But the thing is that, I don't connect to these two controllers through two separate windows basically. It is single window approach. That means through this single window only, through this management server only, I'll be connecting basically. Let me use another color basically. What color I use? Through this server only, I'll be basically, connecting to this software, this server also, and, configuring the routing part. The routing requirement, the control plane requirement also will be done through this management server only. That means I don't connect to this control plane, the centralized control plane software or the centralized control plane server or controller separately. It will be in through this server, management server only, because the thing is that the main thing is what? Single window approach. One single window will provide you everything like that. Okay.
Monitoring parts comes under control plane or management
No,
plane?
management. This will be under this only. Clear, guys, so far?
Yes.
Okay. Now let me wipe up this. Let us talk about now traditional. Okay. Let's take, we have basically, let's say we have only 4 locations like that. You have basically, let's say an organization is there, they have basically 4 locations. Now you tell me, guys, how these 4 locations you'll connect WAN. What will be the WAN services? What are your options basically? First option will be what? If we go, they will have basically maybe dedicated lease lines or lease circuits, correct? You can have basically, let's say we have basically, this is, let's take up that these are the 4 metros, basically Delhi, Mumbai, Kolkata, let's say this Chennai, let's say like that. So we let's say we have these 4 metro cities basically like that. And then basically if this organization want like that, all these 4 metro cities to communicate with each other, they will the WAN service basically they can go for is what? Lease line, lease circuit. These are basically what? Private, basically private connections, correct? But then at the same time, what will be cost? Expensive like that. Since the cost, this lease, the lease line used to be very expensive and all basically, then what happened basically later on? People started going for what? Right? MPLS, like you have basically maybe some cloud is there, some service provider starts offering MPLS service provider, so MPLS, so you take up a connectivity this like that, one single connection. If you see in case of lease line, if Mumbai wanted to communicate with Delhi, basically again I can have basically Mumbai connected to Delhi only, and then Delhi basically connected to Kolkata, Delhi connected to maybe Chennai, like that it could be basically. Or if I wanted, no, Mumbai should communicate with Chennai directly, Mumbai should communicate with Kolkata directly, all the 4 locations should communicate directly with each other. Then if you'll see in the lease line environment, maybe you will require three circuits for each device basically. But if you see in MPLS, basically now having in MPLS, basically you will require only one connection, and using that one connection, now Mumbai can communicate with Delhi also, Mumbai can communicate with Kolkata, Chennai, everyone, right, guys?
Yes.
So compared to MPLS now, compared to lease line, MPLS is what? Little less expensive. But the thing is what? It's not private, it's basically what? Now shared. That's the reason basically you are getting that cost benefit. This cloud, basically this MPLS cloud of the service provider, is not your private cloud basically, that on this from here, like let's say this Mumbai service provider router is there and Delhi service provider router is there. That means from this Mumbai service provider router and Delhi service provider router, only your traffic is going to flow on from here. No, other customers also traffic will flow from the same link basically. So it's a basically shared cloud, correct?
Yes.
What about the security? Suppose if some organization is basically using MPLS to connect their 4 locations basically. What about the what about the security? Like there is network X here, or let's say there is network A here, there is network B here, network C here, network D here, maybe let's say like that, something like that. All these ABCD network we want to communicate. If you're sending the traffic through this shared network, is it possible? there could be some kind of data compromise. Data can be hacked in this cloud. Yes, right? Because if you are going through the service border, they can do an attack, MITM. They can capture the some customers data, and they can maybe they can analyze, decode that data. And once the data is decoded, maybe the data can be misused, maybe the data can be modified, maybe the data will change only totally. The data does not reach the destination. Your information, business critical information can get compromised, correct, in this NPLS environment. So the owners of security is where? On whom? The owners of security is where? On the customer. The customer has to take care of this. Service provider will say, see, we have provided you the connectivity. Okay, you have your reachability between all your locations. Now what you send through our cloud, it is your basically responsibility. If something goes wrong, we are not responsible for that. You have to take care of your own security. And then what this organization will do basically? If I want that my data does not get compromised along the path, what I'll do? I'll tunnel it basically, right? I'll try to hide it basically. Ultimately, basically, we have to, whenever you have shared network, basically, we have to think of what you have to basically bring in what? Your VPN. You need to configure maybe VPNs basically. Like that. Maybe you can configure site to site VPN, or maybe you can configure basically get VPN basically over here, or maybe you can even configure DM VPN. Whatever your solution for VPN, you have to configure that. That is customer's responsibility. The moment shared cloud will come, the shared network is there where different customers traffic will go along. There could be also possibility, maybe the service board engineer, they are not doing any kind of thing, but due to some misconfiguration, maybe something going wrong in the service provider, customer A data can land on customer B router. Due to misconfiguration, one customer's traffic can get forwarded to another customer, possible, right? Maybe that customer, if they receive the traffic, maybe they don't care, they will not go into that traffic. But if somebody wants, since the traffic has landed on their device, maybe they will capture the traffic, and they again study again possibility of what? Data getting compromised. Your confidentiality of the data is not there. So ultimately, security is required, right? When we say VPN, basically ultimately we want to have what? Security. You need to take care of your own data traffic, like that. Every customer has to take care of their own data. How? You cannot simply send your data in clear text across an MPLS, trusting that the MPLS connection is basically secured. Basically nobody else will be able to view the data, nobody else will be able to get the data. Yes, of course, nobody else will get the data, but if required, there can be some violations, and that's the reason security is what? On the customer. So always, whenever you have shared network, basically shared WAN services, security is going to be very critical, like that. Okay, then what is the next now? What is the next third WAN services available today? The third, now the most popular WAN service today is becoming what? Because MPLS is again what? Ultimately, it's not a basically public cloud, it's a private network ultimately. Whereas internet, if you see, basically is what? A public cloud, and the most widely spread network in the world now today. So today, if you see organization, basically ultimately they're basically they're switching over to this option now, internet, because it is the least expensive today, most widely spread, easily available, like that. So if you see now in internet now, the final basically the final WAN service or the most popular WAN service which is available to the public in general is what? Internet. Every home has an internet connection, we can say basically. If you go back basically maybe 30 years back in time, basically people did not have internet in their home. If I wanted to use internet, or if I want to send somebody some email something, maybe I have to go to the work basically, and on the in the work basically, at work basically I get access to the internet, right? Then somewhere, if you see, if you go back 22 years, somewhere in year 2000 or basically 1999, those cyber cafes and all basically started, mushrooming up basically. Everywhere you see, every street has basically multiple cyber cafes offering internet to the public. Then after that, basically ultimately the mobile revolution came in. Now everybody has internet at home, everybody has internet in their own mobiles, like that, because things are becoming cheaper and cheaper every day, like that. So internet is now the most widely spread WAN service being used by organizations for their business requirement also. Again, internet is what? Public cloud. Internet also what? The most insecure network. All right, guys. So
Yes.
again, what will be the customer's requirement? Can we simply send the data across the internet? No. That means you need to take care of, again, your security requirement. Again, you need to configure VPN basically. Again, possible maybe you will configure side-to-side VPNs, or maybe remote access VPNs, or maybe get DM VPN basically. Again, in this basically internet environment, Cisco had a very popular VPN solution, in one of the very popular VPN solution, which was called as what? DM VPN. Like that, dynamic multi-point VPN. The advantage of this DM VPN is what? Basically, this basically had a configuration of like hub and spoke basically environment, like that. This was a scalable solution. The hub configuration you have to do it only once. The hub configuration is done only once, and then you keep on adding the spokes, and you need to just configure the spokes only, like that. Hub side you don't need to, and if you're adding 10 new branches also, you don't need to do any configuration on the hub side, like that. Spoke side you do the configuration for your networking also. Spoke side you do the configuration for your security also, it will be there. Again, you can create in the traditional environment, people used to create the script. Once you created a script for a spoke which is running successfully, spoke is communicating with the hub successfully, the DM VPN is set up between our spoke and the hub successfully, then what you do, it is nothing but duplication. Then you just simply keep on changing the IP addresses, that's it. In the DM VPN, the hub configuration will remain the same, because the hub IP address will be the same for one spoke also. The hub IP address will remain the same for n number of spokes also, correct, guys?
Yes.
So again, but ultimately, who was responsible to doing this security? The customer. They need to have what? Lot of understanding, lot of expertise that you need to have to configure this DM VPN, or to configure basically IPsec VPNs and all. You need to understand all this basically. The IPsec basically, the phase 1, the phase 2. You need to understand the IPsec protocol suite, basically all the components of IPsec VPN family. AH, ESP, your ISAKEM or IKEY version 1, IKEY version 2, basically. And then DVPN also you need to have basically understanding of GRE, multi-point GRE, and then basically Cisco proprietary solution, that is NHRP configuration. Then finally IPC. Basically this DM, lot of configuration, lot of technical expertise was needed to configure all this thing like that. Now we are talking about SD-WAN. Okay, let me just do this. If you see now, as you know, like as I said, now you have basically what? At the moment, basically what I said before this thing, I said there are basically two software you'll require, right? One for the management, and the other one basically was for what? The control plane, right, guys?
Yes.
And as I said, no, this servers must have reachability to all the devices. Now you tell me, you know, now the picture will become clear, correct? If you see now, what I need, I simply require what? An internet connection. That's it. And now you see now, is the server now connected to all the locations? Suppose you have 1,000 locations. Is the server now reachable to all the 1,000 locations?
Yes.
Is it connected physically to any one location, and then that from one location, is it connected to the other location indirectly? No. You don't require multiple connections from the server. You require only one single connection. That means if you see now, the WAN requirement has become simplified. The WAN requirement has become simplified. This servers, and as you can see now, I could have placed both the servers side by side also. So they can be side by side in the same segment also. They can be these servers can be geographically apart anywhere in the world. They can be even hosted on the cloud also. Thing is that you just require what? One reachability connection, one internet will be required.
Abid, in the case you are saying you need connectivity to any one of your router from your network,
No,
or you
no, you see, I'm saying I connected to where? Take example, this server, management server. I connected to where? Did I connect to any one router, or did I connect it to the internet cloud?
yes, you have connected to the internet cloud.
That means normally, if this is a server, ultimately, normally a server has what? Basically, we assign a server what? IP address, correct?
Yes.
And what else do you configure on a server? A default gateway.
Yeah.
So in this case of basically the default gateway will be what? Your ISP internet router. So it is not connected to any particular location. It is connected to what? Internet. And since all the devices basically have the same thing, they have basically connection to the internet. That means they are all reachable to each other. Every device will have a default route pointing to the internet. I'm telling router, let's say this is router 1. I say, hey, router 1, if you want to go anywhere in the world, your next stop IP address is your whatever the ISP in that region. Clear? So
Yeah.
the server is not connected to any one router. The server is basically logically connected to one router also, and the server is logically connected to n number of routers also now because of one single route. So simplified routing is there. If the router basically, let's say this is basically in Kolkata, this is router 4, router 4 has to reach to the server. It is not via maybe router Delhi. It is having an internet route. Only one internet connection is there for every location. You have only one internet connection, basically. And using that one single connection, you are reachable to everybody on the internet.
But practically, the server will be, yeah, okay. If it is in cloud, it is different thing. But practically, if it is in some premises, maybe it will be in the head office, right?
Yeah, it could be in the head office. It could be in a data center itself, like that. The
Okay.
servers. You can place them wherever you want. You want to have your own basically private SD-WAN environment, then you can place your servers in your own HQ, or maybe you can put them in your own data centers, like that. If some organizations are there, they are offering these SD-WAN services, then they will host these SD-WAN servers basically in some cloud basically, and then from the cloud they will be available to the public basically. Ultimately, this server will be where basically? Naturally, it will be in some LAN ultimately, right?
Yes. But if in case it has to manage or do those management process for the routers, the bandwidth for that internet link should be higher, right? So what we are using.
No. Okay.
Router.
Okay. Do we need to do management? Do we need to do the configuration every day? Once you have no. See, initially basically you'll require, let's say when you're just basically deploying this solution, that time maybe this management server need to have reachability to everybody, right?
Yes.
Like that. Take example in a traditional WAN environment. We have, let's say, OSPF router. Okay, so OSPF router, what they do basically? Do they continuously keep on exchanging the database LSS basically? No, right?
No.
Like that. But they still they do sending what to each other, what? Hellos, just to ensure that your neighbors are there, right? Like that. So hello, the traffic to carry this hello, are hello bandwidth intensive? No, right? So same thing over here also. This management server initially will require to access all these devices, but once you configured them, then for monitoring purpose and all, might be just sending some basically small keep alive something kind of, and checking all the devices are available or not, like that. So it all depends on the number of locations. Let's say if you say 1,000 locations are there basically, you want to manage this 1,000 location, naturally maybe somebody will say let us have basically higher bandwidth basically. Somebody will say let us have one gig basically internet connection for this site basically. For somebody, let's say they have only 10 gig basically, 10 location environment is there, then 1 gig might not be the bandwidth needed basically, like that. So it all depends on the size of your deployment, how much bandwidth will be required basically. But today also, if you see now, that is also not a big concern for organizations, because if you see some people nowadays, we have 1 gig connection in our home also now. Like if you take example, Airtel, they're offering basically their fiber basically, they're telling 999 you can get 1 gig basically, 1 gig bandwidth. Like that. Just imagine 1,000 rupees you're getting now 1 gig. That's the price of 1 gig connection. As I told you guys, when I became CCI in 2004 and I joined one of the Cisco's partner, okay, and joined this organization, it was in Mumbai only. I'm basically from Mumbai. So when I joined this organization, in my orientation, the HR guys basically, they were boasting, you were telling, hey Khan, do you know we have 1 Mbps internet connection? And I said, wow, you have 1 Mbps. I was just thinking like 1 Mbps, like if I'm downloading maybe 500 MB or maybe 1 gig file, it will be like maybe 10 minutes, 15 minutes, I'll be able to download something basically, a movie kind of thing, I'm just thinking in the mind. Why? Because when that organization was saying that they have basically 1 Mbps dedicated internet connection, that time, and in my home basically, I was having basically only 64 KB.
Yeah, even if my previous organization, I have seen customer having 64 kbps links.
Yeah, that's what,
MPLS, we have seen MPLS with 64
Yes, 64, because expensive, MPLS and all other, the traditional WAN services were very expensive. Today you see the things have basically reversed basically. Okay, for customers basically we are getting 1 gig for 1,000. Maybe for business environment and all basically this could be maybe 999 also, like that. For from a commercial point of view, this could be basically 1 gig bandwidth you can get for maybe 10K, maybe, who knows. But then still compare this with 10K for 1 gig bandwidth is quite less compared to basically 1 gig MPLS connection. So clear, guys? You don't require very high bandwidth all the time. Basically, this control plane, when it will come, of course it will see, there will be always some kind of basically some basically kind of keep alive mechanism has to be there basically. Otherwise what will happen if one particular WAN this WAN router basically goes down, and this, let's say this Chennai, this network C will not be available. If this the centralized control plane does not is not aware of this network going down, then all the other routers will still, all the other location will still think that the network C is available, because they are not doing any kind of basically kind of checking, because they are getting this information from the centralized control plane. So that means this centralized control plane also needs to keep on checking on all the devices continuously. But then it will be the same like kind of a hello mechanism. You just keep sending a small hello packet, and then if you receive the hello packets, if you don't receive the hello packet, that means you'll consider the network dead. Or whenever, suppose, let's say there is a change in the topology, let's say in Chennai, basically I'm adding a new segment, I'm adding a new basically segment E, basically I add a new location like that. Then what will happen? This Chennai router will inform the centralized control plane, and then the central control plane has to inform all the other location, hey, there is a new network E available via Chennai router, like that. It will inform, and then everybody will say, okay, thank you control plane, we for giving us network E, now we know how to reach E, like that. That time only it has to send this update basically. Clear, guys? So the servers are not connected specifically to one particular location. The servers are basically literally connected to all the locations simultaneously. They don't need to go to a particular location via some other location. They can communicate with every location directly, because it's only one single connection to the internet. Everybody is connected to one single cloud, and that's the reason everybody has only one single connection to go to anywhere in the world. So clear, guys, about the connectivity, guys, how the server is having access to all these location, all these devices for managing and for monitoring.
Yes.
Yes.
Now coming back to security. As I said, the moment internet, people were started using internet, they had to start thinking internet MPLS. People had to start thinking of what? Their data security, the business information which they want to transport across this shared clouds. Basically, the customer has to think of what? Internet, like that. And as I said, in the traditional environment, you need to have people who have a good understanding basically of all this the security requirements, like that. Now what about over here? Basically in Cisco Viptela SD-WAN, basically in Cisco Viptela SD-WAN, security is coming inbuilt. Security is now part of the solution by default. Customer need not bother about this thing. They know, the Viptela guys, they all the vendors of SD-WAN, basically. Let us talk in general SD-WAN. The developers of SD-WAN, they already know the fact that everybody is going to use internet, because this is the most widely spread WAN service available now for everybody, basically. Previously, like let's say you have office basically across the country, like across the country, like let's say there is some US company. Let's take example now Palo Alto, basically Palo Alto and IOPEX, basically. So Palo Alto has an office maybe in US, and maybe IOPEX is having an office in Chennai, and they want this connectivity, private connectivity. What people used to do earlier, if you want to have a private connectivity, people had to go for again lease line also, but basically the lease line across international boundaries, it was called as what? IPLCs, international private lease circuits, like that. Locally domestic, we used to call them as what, lease circuits or lease line. But when a lease line is across continent or across countries, we used to have what, private. Just imagine what would be the cost for this IPLC. That, like as I said, in 2004, basically I was working as a Cisco engineer for JP Morgan Chase in Mumbai for their office. They had basically, you know, from Mumbai basically IPLC to their New York office, like that. Very expensive. Today I'm sure JP Morgan must have basically, you know, thrown away all this thing basically, and they must have basically opted for this internet connectivity. Of course, not like, you know, they will have some kind of, you know, some different kind of SLAs with the ISPs regarding to their WAN requirement, not like public general basically. But then still, this will be, you know, drastically lower. The price will be drastically lower compared to their IPLCs or their MPLS connections basically. So internet is today becoming the most popular, most widely spread WAN service in the world, easily available any to any connectivity. Configuration is so easy. Just one default route you just need to configure to the internet on your device, and now that device is basically, you know, accessible to the whole world. So knowing this, that everybody is going to use ultimately this private services like internet or MPLS, what they did, security they built inbuilt. Once we do the configurations of these devices, now once the devices learns about all this control plane, the control plane learns about all these prefixes, network A, B, C, D, E, like that, all this network it learns, and then it forwards this information to all these WAN routers basically. And when once all these WAN routers basically, they learn about each other's network, how to reach each other's network basically, then ultimately what will happen, a user in network A, let's say, sending a traffic to user in some basically is a user in network D, or maybe some server in network D basically, like that. If the traffic is coming like this, so can this traffic go directly as it is across the internet? No, the traffic will not go as it is directly to the network. Security, as I said, is what, inbuilt. That means what happens, once the user starts sending the traffic, this will be, there will be what, automatic basically, in by default there will be security configured. This data cannot go from one WAN router will never forward the traffic to another WAN, to another location, clear text. It will be by default secured. And through what? IPsec. So the data will be by default secured. The data traffic will be by default secured using IPsec. I don't need to know a damn thing about IPsec. This is the requirement. You don't need to do anything. It will be by default. IPsec will be by default inbuilt, already configured, and by default it is basically already using, you know, like for the hashing algorithm, it is already using basically this algorithm, which is quite strong algorithm for hashing basically, SHA-256 HMAC. So it is already using, and for this thing again, it is also already using for encryption. It is already basically using AES. So it's like basically pre-configured like that. If somebody still wants, some organizations still want that, if they have their network guys are basically, you know, having an understanding of security, understanding the IPsec basically requirement, if you want, you can change from SA basically to SHA-256 to maybe SHA-384 or SHA-512, or maybe you want to use a different encryption algorithm. You want to customize, it is at your, if you want to, but by default this is, according to them, this is a very good combination already inbuilt. I don't need to do, customer don't need to do don't need to have bother. So data, just imagine the data traffic is, inbuilt secured, and I don't need to set up, okay, don't need to configure phase 1, phase 2. I don't need to create crypto maps. I don't need to create some interesting traffic. And that a data packet from one location going towards another location will never go unencrypted, will never go clear text. It will never go, not possible without that.
And also, instead of IPsec, we can use any other tunneling mechanism.
You can see IPsec is the ultimate basically, but if you don't want to use IPsec, you want to use only plain GRE. That means you want to degrade it. It is up to the customer to degrade the security. Because GRE also does the tunneling, right? Encapsulation, like that. But then the data will still go as what? Clear text. And across the internet, it is not recommended basically.
Yes.
So they know that this is the best one, So the best is already pre-configured like that. But still, as you said, yes, we can change the behavior, the default behavior anytime. Okay, this is one concern. Now, second thing is what you see now, these servers, this management server or this control plane servers, this software, ultimately servers basically, these servers are communicating with all these devices, correct? Like maybe, this control plane device is, sending an update. So how this update is going to all the locations? Through the internet. The control plane information is also going through the internet. This management information is also going through the internet. Can this information also be intercepted in the internet cloud? Can this information be compromised? Yes.
Possible.
Because ultimately it is going through the internet cloud. Somebody can capture, maybe the ISP engineers, they can intercept and they will try to, okay, this management is sending, you're doing some configuration, setting some IP address to this one. The ISP engineers, maybe they can manipulate, they will modify and change the IP address and send to your router like that. So this communication, we also have to, since basically we have decided that the customer is going to use the internet, this is our assumption. This is the reason I already explained, because this is the most attractive, most popular now option available to organizations basically. So naturally now this communication is also happening through internet, and you can't let this communication between this servers and all these devices just going as it is. And that's the reason now this data basically also, as I said, customer don't need to bother about all this thing. By default, this communication will also be secured like that. But now this communication basically is, my requirement is what? If you remember basically, if you have an understanding in IPsec basically, okay, basically we have basically, you have the data like that. Okay, for this basically, normally basically the encryption which is used basically, the data is what? Basically very large, right? The data can be very large basically. Like, whereas the authentication information, in IPsec basically the first phase is basically what? Authentication. The authentication information is less compared to the ultimate data of the traffic like that. Okay, so if you see now, for the data traffic, we want to ensure that because data is most critical like that. Data is most critical like that. You can't have the data compromise. That's the reason basically you have this phase there. You want to basically ensure that basically, you want to basically first do authenticate the device, or the device to whom I'm going to send the data encrypted, is that device really the genuine device or not. That's the reason we have authentication phase, correct? between the two devices. We want to ensure that R1 is R1 if it is communicating with R4, and R4 is R4 if it is communicating with R1, like that. Because IP address can be easily hacked. Basically, IP address can be easily hacked. That's the reason we set up the, maybe the pre-shared environment, or maybe the certificate environment, digital certificate environment, and we ensure that basically the devices are genuine. They are as they claim, basically. Same way over here also, when we want this data to, this management data or this control plane data, we also want to ensure that this does not get compromised. So now as I said, this is also by default taken care. This security is also by default taken care. But now you don't require that much stringent security requirement compared to the data. And that's the reason this security is not done by IPsec basically. It is done basically by DTLS tunnels. Data is secured by the customer data is secured by IPsec tunnel, whereas the management, the information management traffic or the control plane traffic, this all traffic is basically handled by DTLS. And whenever you have basically TLS, DTLS ultimately means what? Dynamic TLS. TLS basically means what? SSL VPN. And in SSL VPN, basically what we have basically, you have basically what? The public key influence, basically you have basically the digital certificates, right? So we have basically, it's not basically 2 or 4 locations like that. We are thinking of what? A scalable solution. Today, basically, we have basically only 4 locations. Tomorrow, this can be 400 locations. So you can't have a manual pre-shared environment basically. So very scalable internet standard solution is what? Every device must have what? A digital certificate. So in SD-WAN, basically, when we are setting up this SD-WAN, every device must have a valid digital certificate, duly signed by a certificate authority. You need to have a certificate authority signed digital certificate on each and every device, like that. And once they have this thing, whenever they're communicating with this, they will set up this DTLS tunnels between them, and then their communication will always go encrypted inside this. So it will not go the same thing right now. How we use basically on the internet, all the web communication which is happening, it is basically the TLS communication which is happening. We don't want to send data clear text across the internet any longer. Same thing over here also. This like that. This is a professional environment. Professional environment, you can't let a single packet go clear text across your internet cloud.
That digital certification cannot be compromised, right? It will be unique, or how?
Yeah, it
how
will be unique, because ultimately you will be taking up the in a real environment, you will be taking up the services from a basically third party trusted CS service providers, basically, like maybe you will go for VeriSign, basically Entrust, Baltimore, or maybe Microsoft, or maybe there are so many like root CS server providers basically. So it is a requirement, it is a part of the SD-WAN with Cisco Viptela SD-WAN, that you need to have this environment there basically. And in fact, actually, what this, as I said, Viptela is basically, see, Cisco also provide root certificate services, okay, like that. Now the thing is that before Cisco took over Viptela is an independent separate organization, correct? Like that.
Yeah.
So what actually they did, they already had for this digital certificate requirement, this environment, if you want like that scalable environment for authentication and basically your traffic security, they already did a tie-up with Symantec. I'll show you that. So they already have an inbuilt, the default, it will default point to Symantec CA services basically, like that. But customer has option that, okay, you don't want to take the service from CA, you want to take it from some other company, you can take it from some other vendor, or you want to set up your own basically CA services, that is available like that. So
So,
Wiptel already has that. Yes.
okay. And you meant digital certificate for each and every device. That means what and all the devices that are in our network, like routers, or you mean to say the
No,
servers?
we are talking about WAN basically, right? Like,
Oh, yeah.
see now, as I said, as you said server, let's say here in network A, you have a server here like that, okay? And in network D, basically you have a user here, basically. This is a user who is communicating with this some server, basically some your application server is there. Now SD-WAN basically is not concerned with your what is going, how you are sending, because from this server, this user, you can send the data clear text, but once it comes to the exit point, your this WAN router basically will not allow the traffic to go clear text.
Okay.
So we are talking about WAN, SD-WAN. What you have in your LAN, that is something different. You want that traffic to still go clear text, you allow the traffic to go clear text, or if you still want the traffic, your users, whenever they are communicating basically with their servers, basically that traffic must be encrypted again using basically SSL VPNs or basically like that, then that is again, that is a separate thing basically. When I say each and every device, I'm talking about the WAN devices, not the whole network.
Yes. So in such case, do I say like it's like licensing for devices, or how many devices I can have?
Yes. See, one simple thing is that whenever software comes, along with software, licensing will always come.
Yeah.
That is the bitter truth, the reality, we can say. You buy any software, the moment you'll buy software, they will ask you, you want the software for single user, or you want for maybe the company, right? Like that. So same thing applies here. Ultimately, this is a software they are going to sell to a customer basically. So they will always ask, okay, how many locations you want basically? What is your requirement? Like you'll say that yes, today right now basically I want to have this basically only for 10 locations basically, but tomorrow maybe I will will go for 100 locations. They'll say, okay, no problem, now you buy licensing for only 10 locations.
Yeah. So
tomorrow,
that's where the problem is, right? So they will offer like bulk, like 100, 150, and 120. You can't
like
go
that.
for 110 if you're having 112 devices. But either way, you have to go for 100 or 150 then. That is where the problem.
That is what it will not be like, 1:1 basically. It will never be like that.
Yeah.
It will be always like that, okay, because ultimately this is basically this solution is not meant for a very small organization. It will be a very expensive solution, right? Not well, like 3-4 location organization cannot afford this basically. Softwares are always expensive.
Yes.
Like that. If you take a laptop, he'll buy a laptop, maybe you'll get a laptop for 50,000. But once if you want to install basically licensed software, that might cost basically 100,000 plus. Like that. So softwares are always expensive basically compared to the hardware basically. Like that.
This will vary from the device licensing, right? So the validity and the support that is being given for
that will be different. Yes, that will be different. Yes, device licensing will be also there, and plus basically you will require licensing for your SD-WAN solution also. I'll come to that. I'll show you exactly what and where will be, how that will be taken care of basically.
Abid, Kiran, is there a possible, I mean, is there any link-based licensing also there?
Link-based means I don't.
Instead of see one device, I am connecting only one link to towards the WAN line.
No. It is not basically one per link. Basically, you can go for multiple WAN services, multiple WAN links. Naturally, if you see, when we are talking about, like take example here, when we are talking about large deployment scenarios, do you think that this 4 locations will have only single connection, single WAN service? Just imagine, like if this Delhi router, you have only one internet connection. If this link fails, basically, then Delhi will become isolated. Correct? Like that. In a real world environment, naturally you'll always have basically another WAN service also, no, backup.
Yeah, ideally.
like that. So there will be more than one. It will not be a single WAN service basically. So that is independent about the licensing.
So it should be device based.
Yeah, device specific. You can go for a single WAN service. You can go for 4 WAN service if required. It has nothing to do with the licensing basically.
Yeah, thanks.
Yeah. Okay. All right. Now the thing is that we have spoken about all this thing. I'll do one thing now. We'll take a small break now. It's like 2 hours, so that recording also becomes like 2 hours recording. It will become. You don't have to watch a whole 4 hours, 5 hours single recording, at one time basically. So I'll stop the recording and I'll restart the recording after a 5. We'll take a 5 minutes break.
10 minutes break.
10 minutes break we'll take. Okay. Let us have a 10 minutes break then. Okay. So I'm just going to stop the recording first.